Example number 6. In earlier times, ethyl ether was commonly used as an anesthetic. It is, however, highly flammable. When 5 milliliters of ethyl ether is burned in a bomb calorimeter, the temperature rises from 23.5 degrees Celsius to 39.7 degrees Celsius. If the calorimeter heat capacity is 10.34 kilojoules per degree Celsius and the density of ethyl ether is 0.714 grams per milliliter, find the heat absorbed by the calorimeter. Okay, so in this problem, ang gihatag is the calorimeter heat capacity already. Okay, let me highlight that. Calorimeter heat capacity, which means that this refers to the heat capacity of the entire calorimeter, including both the bomb and water. The problem here is we have to find the heat absorbed by the calorimeter based on the reaction. Okay, so the formula is Q calorimeter is equal to C delta T. Very simple. And because the heat capacity of the calorimeter is already given, that's 10.34 kilojoules per degree Celsius, and the change in temperature of the calorimeter is given. So we have here the final temperature, and this is the initial temperature. So final minus initial, so that's 39.7 degrees Celsius minus 23.5 degrees Celsius. And so the heat absorbed by the calorimeter is, I want you to compute with me. I want you to get your calculators and compute. So the answer is, that is 167.51, and the unit is kilojoules. So in this problem, ang kaning 5 ml nga ether o kaniyang density, wala ra sila gamit because automatic naman nga nagihatag na niya ang heat capacity ug ang change in temperature. Example number 7. A calorimeter is to be used to compare the energy content of some fuels. In the calibration of the calorimeter, an electrical heater supplies 100 joules of heat and a temperature increase of 0.85 degrees Celsius is observed. Then, 0.245 grams of a particular fuel is burned in this same calorimeter, and the temperature increases by 5.23 degrees Celsius. Calculate the energy density of this fuel, which is the amount of energy liberated per gram of fuel burned. In this example, there are two parts. So this part, which is the calibration, and the second part where the particular fuel is burned, and we are going to, so this is the burning of the fuel. So in the first part, in the calibration, okay, let's write calibration. It says here that 100 joules of heat is supplied. Using an electrical heater, 100 joules of heat is applied to the calorimeter. So if this amount of heat is applied to the calorimeter, then this is the amount of heat absorbed by the calorimeter. So this is Q cal. That's 100 joules of heat. And when the calorimeter absorbed this amount of heat, there is a corresponding increase in temperature of 0.85 degrees Celsius. Calibration is done to find the heat capacity of the calorimeter. Now remember, Q cal equals C delta T. So C is equal to Q cal over delta T. So that's 100 joules over 0.85 degrees Celsius. That would give us an answer of, if it's in fraction, that's 20 over 17 joules per degree Celsius. Or if you round that off up to the second decimal place, that would give us 1.18 joules per degree Celsius. Remember that we can just write this the rounded off nga, we can round it off up to the second decimal place, pero inig-solve kay kinahanglan it must be the whole, the entire nga value, not the rounded off value, because this is not yet the final answer. So for the burning of the fuel, there is, so the mass of the fuel is 0.245 grams using the same calorimeter, and there is a temperature increase of 5.23 degrees Celsius. Calculate the energy density of this fuel, which is the amount of energy liberated per gram of the fuel burned. So if you talk about energy density, the formula class is negative Q fuel, meaning that's for the reaction, divided by the mass of the fuel burned. So we need to find this value first. So Q fuel equals negative Q calorimeter, right? That's Q fuel here means the reaction, the heat of the reaction in burning the fuel. We already know the heat capacity of the calorimeter and the change in temperature here when the fuel was burned. So that's negative, let's use the fraction form, 20 over 17 joules per degree Celsius times the change in temperature, 5.23 degrees Celsius. So the heat of the reaction is, that's 6.15 joules. That's negative. So we can now compute for the energy density. So energy density equals negative of negative 6.15 joules divided by the mass of the fuel burned, which is 0.245 grams. So we divide, and so the energy density is approximately 25.11 joules per gram. So unsay pasabot ani niya? This is the amount of heat liberated per gram of the fuel burned. That's energy density. Okay, let's answer this. Check your learning. A 0.5 gram sample of trinitrotoluene with the formula C7H5N2O6 is burned in a bomb calorimeter containing 610 grams of water at an initial temperature of 20 degrees Celsius. The heat capacity of the bomb is 420 joules per degree Celsius, and the heat of combustion of TNT is 3374 kilojoules per mole. Calculate the final temperature of the water and the calorimeter once the reaction is complete. Okay, so in this example, gilahi si water ug si bomb. So walay total nga heat capacity. So naay sample nga nakunoy mass sa TNT nga 0.5 grams. And then for the bomb, ang water, ihang mass kay 610 grams, and it has an initial temperature of 20 degrees Celsius. The heat capacity of the bomb is 420 joules per degree Celsius. The heat of combustion of TNT, so that's Q combustion of TNT, is 3374 kilojoules per mole. So, ang pangutana, pilay final nga temperature sa water. Alright, so what will be our working equation? The working equation is, so Q reaction equals negative quantity Q water plus Q bump. So, lahi si water ug si bump. Ang gipangita nato ang final temperature ni water, which is at the same time the final temperature of the bump. But for us to find that, we need to find the heat of the reaction. Okay? So, if naay 3374 kilojoules of heat, this is negative because combustion man, released. For every 1 mole of TNT, this refers to TNT, pila may heat sa reaction, pila may ma-release nga heat if 0.5 grams of TNT ang na-burn. Okay, so what we're going to do now is to solve. Okay, solve Q reaction when 0.5 gram TNT is burned. So first thing, we solve for the molar mass of TNT. So naay 7 ka carbon plus 5 ka hydrogen plus 2 ka nitrogen plus 6 ka oxygen. So the atomic mass of carbon is 12 plus 5 times 1 plus 2 times 14 plus 6 times 16. Okay, can you please compute that? 7 times 12 plus 5 plus 28 plus 6 times 16. And that is equal to 213, that's grams per mole. Okay, so that's 213 grams per mole. So what are we going to do with that? We are going to use that to find the equivalent or the heat of the reaction based on this mass of the sample used. So, Q reaction equals, pila to'y mass? Okay, that's 0.5 grams of TNT. But we know nga for every 1 mole of TNT, equivalent na siya sa 213 grams nga TNT. So this is the molar mass nga itong gigamit. So na-cancel si grams. And gihatagan man ta og heat of combustion ni TNT. Nga for every 1 mole kuno of TNT burned, there's 3374 kilojoules of heat nga ma-release. So we're going to use that here. 3374 kilojoules of heat released for every 1 mole of TNT. So na-cancel. This is for TNT. Cancel. So the heat of the reaction therefore is, it's 0.5 times 3374 divided by 213. The answer is approximately 7.92 kilojoules. That's the amount of heat released for every 0.5 grams of TNT burned. So we can now solve for final temperature. So balik ta sa atong equation. Q reaction equals negative Q of water plus Q of the bomb. So our Q reaction is negative. So let's make this joules. This is negative 7,920 joules. okay, equals negative. Let's change this into the formula. MC delta T plus C delta T. So, unsay common? Delta T. So, atong i-factor out, by the way, we will cancel both negative signs, the negative signs on both sides, and then we will factor out delta T, butang nato sa gawas, and ipabili nato sa sulod ang MC and C. So, that's factoring. But delta T class is final temperature minus the initial temperature. Diba? Times MC plus C. So, we have the initial temperature. We have the mass of unsa man ni? That's the water. And this is for the specific heat capacity of the water. And this is the heat capacity of the bomb. So, we can now substitute. So, this is 7,920 joules equals the unknown final temperature minus, balik ta kung pila itong initial. Okay, it's 20 degrees Celsius. Times, pila ito yung masa itong tubig? Okay, it's 610 grams. Times 4.18 joules per gram degrees Celsius. Plus, pila ito yung heat capacity sa atong bomb? Okay, it's 420. 420 joules per degree Celsius. Okay, so na-cancel ni ang grams. No? Ma-cancel ang grams, ana niya. So, compute. This is TF minus 20 degrees Celsius. And, pila man ang naa sa sulod tanan? 610 times 4.18. And then you add that to 420. And you will get an answer of 2969.8 joules per degree Celsius. And that's equal to 7,920 joules. And then we're going to divide the entire thing. Divide by 2969.8. Divide both sides by 2969.8 joules per degree Celsius. So, ang pikas kay mahimong pila man ang 7,920 divided by 2969.8. It will give us approximately an answer of 2.67. And when you divide joules divided by joules degrees Celsius, ang unit na mabilin kay degree Celsius. Final temperature equal minus 20 degrees Celsius. And then we transpose this to the other side. And so the final temperature is 2.67 degrees Celsius plus 20 degrees Celsius. And so the final temperature of the water and the bomb is 22.67 degrees Celsius. Okay, that's for check your learning. Another check your learning. When 1 mole of caffeine with the formula C8H10N4O2 is burned in air, 4,960 kilojoules of heat is evolved, meaning exothermic. 5 grams of caffeine is burned in a bomb calorimeter. The temperature is observed to increase by 11.37 degrees Celsius. What is the heat capacity of the calorimeter? So this time, ang atong gipangita, heat capacity, C. Pila na siya. So, it didn't mention anything about the bomb or the water, wala gi-separate. So, meaning we're talking about here about the total heat capacity of the calorimeter. We are given a change in temperature of 11.37 degrees Celsius. And we are given here the heat of combustion. So, Q combustion of the caffeine, no? So, that's negative 4,960 kilojoules over per 1 mole of caffeine burned. So we put a negative sign because it is evolved. But dili man 1 mole ang gigamit sa calorimeter. Instead, pila gigamit sa calorimeter? It's 5 grams. And this 5 grams caused an increase in temperature of 11.37 degrees Celsius. So pilay heat capacity. So the working formula is still Q reaction equals negative Q calorimeter. The difference ani niya sa previous nga check your learning is that kadtong previous kay gilahi si bomb ug si water, but this time kanang giusa ra siya. So this ang Q cal is negative C delta T. So nangita ta ni C, we already have delta T. So kinahanglan natay Q reaction. So we have to solve for that first. Pila ang Q reaction when 5 grams of caffeine burned? Okay, so solve Q reaction when 5 grams caffeine is burned. So first thing to do is to find the molar mass of the caffeine burned. So na 8 ka carbon plus 10 ka hydrogen plus 4 ka nitrogen plus 2 ka oxygen. So that carbon atomic mass is 8 plus hydrogen is 1 plus nitrogen is 14 plus oxygen is 16. And could you please compute kung pila na siya? Alright, so the answer is 194 grams per mole. And because we have this already, then we can compute na for the Q reaction. So we start with pila may gigamit nga mass. That's 5 grams. Sa 5 grams nga caffeine, we know nga for every 194 grams of this caffeine, that's equivalent to 1 mole of caffeine. And we know that for every 1 mole of caffeine burned, there's 4,960 kilojoules of heat released. Cancel si grams, cancel si mole, ang nahabilin kay kilojoules. So 4,960 times 5 divided by 194, we get approximately, that's negative 127.84 kilojoules, but we have to convert this to joules, so that's negative 127,840 joules. But remember, this is just a rounded off value, but we don't actually use this value in solving here. Okay? Kinahanglan ang whole value ang gamiton. So, we can now substitute that. Okay, we substitute. So, that's negative 127,840 joules equals negative C, and the change in temperature is 11.37 degrees Celsius. So we cancel out the negative sign and we divide, so C equals 127,840 joules divided by 11.37 degrees Celsius. And pila answer? The answer is 11,243.19 joules per degree Celsius. But also, we can still express it in terms of kilojoules. Pwede ra sad gihapon. And that would be 11.24 kilojoules per degrees Celsius. So this is the heat capacity of the calorimeter.